Okay, here we go, unfamiliar question time, and you know fine well that that's the kind of thing you're going to get. They're not going to give you a straightforward, this is this and this is this, like Mendel's peas, sort it out, draw me a lovely Punnett square. They're going to leave that for the more complex crosses. If they ask you about monohybrid crosses, then they're going to give you some, some horrid looking graph thing like this, or some data to deal with, or a metabolic pathway, something. So we've got quite a lot of information here we need to read. So we've got in wheat, the flag leaf is the leaf on the stalk which carries the grain. Super duper. The concentration of chlorophyll, so that's our characteristic, concentration of chlorophyll is determined by a single gene. Single gene, that means we're dealing with monohybrid cross. That's great. So we can put that down. Monohybrid, one characteristic. The allele for high concentration, big H, it's a bit of a giveaway, is dominant. So the allele for low concentration, we're going to call that little h. A cross was carried out in which the plants of the genotype big H, and little h, that's our pure breeders, crossed to produce an F1 generation. The F1 interbreed to produce an F2 generation. So this is kind of a bit like the Mendel's cross that we just did. The graphs show the chlorophyll concentration in the flag leaves of the parent plants, the F1 and the F2. So our parent plants, so these are our big H, little h, and this down here is not labelled, it's labelled all the way down here, chlorophyll concentration. So what we're saying is this has a low one and this has a high one. That's what we're expecting, because these have two, they're homozygous for the high concentration, they're homozygous for the low. F1 generation, so now I'm thinking, okay, so they're the parents, big H, little h, and I'm expecting them to give, because I've learnt my genetics, big H, little h, so all of these are going to be big H, little h, and I'm expecting them all to have the high concentration, and that is shown, isn't it? And then we got to the F2 generation, where we're doing big H, little h crossed with big H, little h, and I'm expecting a 3:1 ratio of the ones with that genotype and high chlorophyll to the ones with that genotype. Now does that look like I've got that? I've got 16 plus all these other ones of high, and then I've just got 6 of those. Okay, so that looks like it might be a 3:1 ratio. So let's have a look at the question. What is the evidence? Evidence from the graph. So I need to talk about the graph. That the allele for high chlorophyll concentration is dominant to that for low. So here we're looking at the F1 generation, where they've pretty much all got high concentration. So in the F1 generation, the plants are heterozygous. Oh, can't spell. Again, heterozygous. Could be my tag, that I can't spell. Heterozygous, and all have high chlorophyll. Ooh, can I squeeze in concentration? I think I probably can. Okay, so that's our next question. What is the evidence from the graph, let's be starting up there again, that the environment has an effect on chlorophyll concentration? So Phenotype, what you look like, depends not only on what you inherit, but also on the environment. An environment can cause an increased variation. So here we've got a variant between 3.1 and 3.5. Most of them are 3.1 to 3.3. So we've got variation, and we've got variation, we're spanning two categories here. So the chlorophyll concentration of parent, and it's quite difficult to sort it out from F2 actually, because they seem to be a little bit all over the place. So I'm just going to concentrate on parent and F1. Spans more than one category of the histogram. X-axis. So, phew. Explain. Ooh, give a reason. Give a reason that we've got both types. So we've got that type and this type in the F2 generation. So the cross would lead to an expected 3:1 ratio of high to low chlorophyll concentration. And you wouldn't necessarily, I don't think in this case, need, because you've just been given lines to write on, be expected to carry out that cross. You could just jump straight to it. You are expected to know these very common ratios. You could put as two heterozygotes have been crossed. The high peaks correspond to big H, big H, big H, little h plants, and low peaks to little h plants. In an approximate 3:1 ratio. And I guess the other way of doing that would be, as long as you sort of, you know, would be to put a little cross here. So big H, little h, cross big H, little h, put the gametes in. You're then absolutely certain the examiner knows that you know what you're talking about. Little Punnett square, big H, little h, big H, little h. And then those two genotypes give you high, that one gives you low. And certainly if you're sort of, you know, you're doing a cross and you're not quite sure what's going out, a little cross, if it works, great. If it doesn't, you've done the wrong thing and you can go back. Genetics is great because you can always check. So, describe the shape of the graph. You would expect, if you determine the concentration of chlorophyll in these plants, an F1 plant and a recessive homozygote. Now there you really are going to have to do the cross, I think. So we've got I want to leave some room to write my answer because I want to describe the shape of the graph, but I first need to know what my offspring will look like. So F1 plants has the genotype big H, little h. And I'm going to cross it with the recessive homozygote, little h, little h. My gametes are going to be that for that plant and just little h for that plant. Put them into a Punnett square, parent 1 across the top, parent 2 down the side. So I'll get, that one will be high and that one will be low. So I'm going to get a 1-to-1 ratio there. So then what does that mean for the graph? Well, it will mean that I would have equally high, so I'll get equal I'm reluctant to call them peaks, but I will. Peaks for high and low. So it'd effectively be like that graph, but these would be big H, little h ones. And I'm going to put chlorophyll concentration. I don't know what, I've read it. Super duper.